Hi, this is Hyunsuk Yu, your 5111TA, and today we'll be discussing oxidation and reduction in preparation for your midterm 3. So here are the things that you need to know for midterm 3. First, determining the oxidation state. Second, balancing the redox equation. Third, using Faraday's law to calculate the total amount of charge passed in a given time. Fourth, determining the cell potential using the relationship delta G is equal to minus NF delta E. And from that, predicting whether a reaction is spontaneous or non-spontaneous. And finally, using Nernst equation to calculate E. So, let's begin by discussing how you determine the oxidation state. So when you determine the oxidation state, you follow these simple rules. First, free elements have oxidation number of 0. Second, alkali metals have oxidation number of +1, while alkali earth-like metals have oxidation number of +2. And aluminum usually has +3 oxidation state. And oxygen has oxidation number of -2, except for peroxides where oxygen has oxidation number of -1. And hydrogen also usually have oxidation number of +1, except for metal hydrides where it has an oxidation number of -1. And halogens usually have oxidation number of -1. And when you determine the oxidation number, you can double check if it's correct by checking whether the sum of the oxidation numbers equal the net charge of the ion. Now, let's talk about balancing the redox equation. When you balance the redox equation, you first assign the oxidation numbers. When you assign the oxidation numbers, you can determine which species is being oxidized and which species is being reduced. And you write down the corresponding reduction and oxidation half reactions. And you balance each half reaction using the fact that in acidic conditions, you use water to balance oxygen, whereas you use proton to balance hydrogen. And you multiply half reactions such that the number of electrons in the oxidation half reaction matches the number of electrons in the reduction half reaction. And finally, you sum the half reactions and make appropriate cancellations. Now let's move on to discuss how you determine the cell potential. So when you determine the cell potential, you use the fact that delta E of the cell is equal to E of the reduction half reaction minus the E of oxidation half reaction. And it is very important that you don't multiply coefficients when you calculate the cell potential. And this is because E is an intensive property. And from the relationship delta G is equal to -NF delta E, we know that the reaction is spontaneous if and only if delta E is greater than 0. And as a note, galvanic cells are the cells where spontaneous chemical reactions are used to drive an electric current, whereas electrolytic cells are the cells where electric energy is used to drive a non-spontaneous reaction. Now, let's talk about Nernst equation. So in Nernst equation, delta E of cell is equal to delta E naught of the cell minus RT over NF all in Q. And this is further simplified to delta E is equal to delta E naught minus 0.0592 over N log of Q. And of course, this simplification holds at room temperature. And if the reaction is in equilibrium, Q is equal to K, and you have our expression for K in terms of delta E. Now, let's talk about the actual question in midterm 3. First question, calculate the standard reduction potential for the galvanic cell. So to solve this question, you use the fact that in the cathode, permanganate ion is being reduced to manganese 2, whereas in the anode, zinc is being oxidized to zinc 2+. So as discussed earlier, delta E of the cell is equal to E cathode minus E anode, and thus you can calculate the delta E of cell to be 2.25 volts. Now, write down the oxidation number. So we know that oxygen has an oxidation number of -2, and if we denote the oxidation number of manganese as X, we can set up a simple equation and we can calculate the oxidation state to be +7. Now, we have to balance the equation for overall reaction that happens in this galvanic cell. So zinc oxidizes to zinc 2+ in the oxidation half reaction, and permanganate is being reduced to manganese 2. And we balance oxygen with water, and we balance hydrogen with protons. So we multiply necessary coefficients to cancel out electrons, and we end up with the answer. Now, which species is a better oxidizing agent? So an oxidizing agent is a species that itself is reduced while it oxidizes other species. So to determine if a species is a better oxidizing agent, you have to compare the reduction potential. So a species that has a higher reduction potential will be a better oxidizing agent. And since permanganate has a higher reduction potential than zinc 2+, we know that permanganate is a better oxidation agent. Now, calculate the current generated by 0.037 mole of electron in 1 hour. So, since 1 mole of electron contains 96485 coulomb of charge, 0.037 mole of electron contains 3569.9 coulombs. So you divide that by the time, which is 3600 seconds, to get the current, which is 1 ampere. And that was the end of this review session. Everyone, good luck with the midterm.